Alright, bam. Here's our next example for angle elevation and angle depression notes. Calais, the honey badger, is laying 13 feet away from a tree. She looks up at a beehive at an angle of 63 degrees. How high up in a tree is the beehive? You guys ever seen that? The honey badger? No, yeah. Okay. I need you guys to try to draw. Alright, I gave you enough time to draw this picture. I think that's Kalia. Is that how you say Kalia? Kalia the honey badger. He doesn't care about anybody. Alright. So, he's laying from a tree. So, here, let's draw a tree right here. This is my tree. Tree. Look at that tree. Okay. He's laying 13 feet from a tree. So, let's draw 13 feet right here. I got to be very detailed in my picture. And I'm going to draw a honey badger. And he's laying down. He's not dead. Okay. There's his legs up there. And he's just like chilling right here. And his beady little eyes. Okay. Yeah, that's a honey badger. Don't ask me. Okay. That works. Alright, so he's looking up at the tree at an angle of elevation. Okay, so that makes sense. Elevation is, going up from a horizontal line. Up at a tree, and there's a beehive up there. Let's draw a red for a beehive. This is my beehive. Whoa, that's a crazy beehive. Look at all the bees around that. Okay, so he's looking up at it, and I have to label what angle it is. It's 63 degrees. Okay. How high up in the tree is the beehive? Isn't that crazy? You're only given two numbers right here, 13 and 63, and you're supposed to know how to figure out the height of this tree. And is that really the height of the tree? I mean, maybe this beehive should be on the top, so it's really the height of the tree, right? Right? Yeah. What a weird question. But anyways, I understand what they're trying to get at. Can we find the height right now, or how high? Oh, wait, no, it says how high up in the tree is the beehive. Okay, that makes sense. Okay, so it's not how tall the tree is, how high up in the tree is the beehive. So, two numbers. We have two numbers. How are we going to find that? Yeah? Tangent! Okay, check this out. We have a right triangle right here. There's a right angle right here. Here's your right triangle. Bam! Look at that right triangle. It's green. Okay, so we can use tangent because this side right here is opposite of this angle, and this is adjacent. So if I say tangent of 63 degrees equals, I can put the opposite side, which is the height of the beehive, and then the adjacent side, which is 13 right there. So how do I get this h alone? Multiply. So I multiply by 13 on both sides. Very good. Thank you for your answers. I have 13 times tangent of 63 degrees equals h. Alright, how do I find the h? Oh yeah, you just had to multiply there. Okay, so that's your answer. I'm happy with that answer. If I say no calculator on the test, that's the answer I want you to have. If I say calculator, then I want you to do this. It is approximately, we go tangent of 63 degrees and multiply it by 13. Do it, do it. What'd you get?
25.5 feet.
25, give me some decimals. 0.51. Alright, that's cool. Let's just say 0.5. Alright, and that's feet, right?
Yeah.
Okay, there you have it. Alright, now if I read the next one and draw a picture, it might look something like this. Let's see, we need a wall. I need a wall. Let's see, this is going to be my wall. And it says the ladder is resting against it. The bottom of the ladder is 3.5 feet away from the wall. So, let's see, a ladder like that is resting against it. There's a ladder. And I'm going to draw little things right here because it's a ladder. Okay, that looks good. That's a pretty good ladder. And it's 3.5 feet away from, away from the wall. Okay. What's the question? What is the angle of elevation? So it wants to know this angle right here. Let's call this angle X, because that's what it's asking. It says, what is the angle of elevation? Alright, is my picture good?
No, you're missing the height of the ladder.
Yes, it is not good. I'm missing something. Yes, you see this right here? It says it's a 9-foot ladder. You got a 9-foot ladder. You got to put that on there. So I'm gonna put a 9 on there. It's a 9-foot ladder. All right. Okay, now we're looking for this x. What trig function uses the 3.5, the x, and the 9?
Cosine.
Cosine. Yes, because 3.5 is adjacent. So I'm gonna say cosine of x, which looks like that. X, and then equals 3.5 over 9. All right, how do I get that x alone? I want to get him out of cosine. What do I do? What do I do? What does cosine do in the x? Oh, it's doing the cosine of it, right? How do you undo a cosine? I got to get the x out of the cosine. Cosine is not multiplying the x. Don't say that. It's not doing that. Yeah, wait. Do the inverse of cosine. Like that. Okay, so we do inverse of cosine, cosine like that. Okay, and then these cancel out. You get really excited because your x is alone. Calm down. Then we have cosine of -1. We have 3.5 divided by 9. Guys, do that. Tell me what you get. Wait, say it again. You said 67?
Yeah, 67.
Okay. Now, we're going to say 67 degrees. We're not going to do decimals. Even though if you do decimals, you're still technically correct. We are rounding. I'm going to round it to the nearest degree, because that's most of the time you round to the nearest degree when you have degree problems. This problem doesn't tell you what to round it to, so I'm just going to put 67. So there's 67 degrees. That is the angle of elevation that the ladder is resting at. Okay, here is the last example I would like to work on with you guys. It says a glider. It should say a glider flies horizontally, because that might help you out to figure out what a glider is. Horizontally, for every 2 meters of altitude it loses, what is its glide angle? Hey guys, can you tell me what altitude means? Because some people might see that and freak out. Yeah? What does it mean?
It's like height.
It's like height?
Yeah.
Is it like height? Okay, you're right. Alright, draw a picture. Alright, so glider is an airplane, so I'm going to draw an airplane. Let's see. Oh, it's kind of like an airplane. Okay, if it moves 15 feet, like this is the glider right here. It's moving 15 feet. What happens to it? It drops. It drops how much? 2 meters. Okay, so here's my glider now. It dropped 2 meters after it glided for 15 meters. Okay, let's put an M right there so we know what's going on. All right, now it says, what is its glide angle? Like, what's it flying at? So that is this angle right here. That's what it's talking about. It's talking about the angle that it's flying at, like where's the nose pointed on the plane. Maybe I should draw this differently. It should be like more like this. It's kind of like flying downward. What is that angle? Well, what trig function are we going to use to find this angle? I'm going to use a new variable for you guys. It's called theta. Ooh, theta. It kind of looks like a 0 with a toupee. Some people draw it like this, and therefore it looks like a 0 with the top hat on. Okay, what trig function? Shout it out. Let's go. Tangent. All right, people like to learn. People who like to learn like to talk. Okay, and what's my angle for this one? Say it. Theta. Theta. Okay, this is how you spell theta, guys, so you guys get used to it. It's Theta. That's how you say it, theta. Okay, theta equals, what's my opposite? Tangent of theta equals, what's my opposite? Dose. And what's my adjacent? 15. If you want to learn something, you're participating. Now, how do I get theta alone? Because that's what I'm trying to find. It says find its glide angle, so I need to know what theta is. How do I get theta out of tangent? Yeah, you take the inverse tangent. I love that word. Inverse. And so I'm going to go inverse tangent of this side right here. And let's see what I get. That guy crosses out. We're left with theta. Theta's chilling right here. And now we have tangent, inverse. You can also use arctangent. Arctangent is used sometimes because that's how they used to say it. They used to say arctangent instead of tangent inverse with the -1. So that would be 3 over 15. I just want to show you guys what it looks like right there. That's not the answer. That's another way to write tangent inverse. Okay, so once I plug that into my calculator, what do you guys get? It goes 2 divided by 15, tangent inverse of that. What do you guys get? What'd you get?
7.59.
Yeah, 7.59. So if I approximate that, 7.59, I would be rounding stuff. And I'd probably round it to approximately 7.6. Oh, wait. No, let's round to the nearest whole degree. What is that going to be? 8 degrees, right? Right? So we see the 5, we round the 7 up to 8. There you have it. Okay. Now, I kind of said this at the beginning of the video, but I want you guys to try this on your own too. Write down 3 strategies that you can use to help make sure you understand the problem completely.